In this video, we're going to look at how to solve systems of equations, specifically linear quadratic systems. So a system of equations is just a set of two or more equations, and they could create any graph, linear, quadratic, exponential, anything. And solving a system of equations, what that means is we're finding the points of intersection of those equations. So a system of equations is just a set of equations, could be linear, quadratic, exponential, sinusoidal, anything. And to solve a system just means finding the points of intersection. So let's take a look at this system right here. We have two functions. One of them is a parabola. We see that degree of 2. And one of them is linear. And we are asked to solve this system, which means we're finding the points of intersection. So we did this in grade 10 when we were finding the points of intersection between linear systems, so two or more lines, and we would use elimination or substitution. The easiest way to find points of intersection of any functions is just set them equal to each other. Check what x has to equal if we know the y values are the same. So this is just substitution, substituting one variable into the other. So we're going to substitute one y in for the other y. So we're just going to set these equal to each other. So we're going to say that if we're looking for a point of intersection, we're going to say, well, what would happen if these y values were equal to each other? So we're going to set them equal to each other, and we are left with this equation here. And now all we have to do is solve it. So really solving a system of equations is not very difficult. It just set them equal to each other and now just use our tools of solving. So I'm going to bring everything onto one side so that we can start simplifying this guy and then choosing a strategy to solve it. We've got some like terms here. So I'm going to bring those x's together. Done. So how can we solve this? We know it's a quadratic, so we could factor, we could do quadratic formula. I see this ugly decimal here, so I think I'm going to use the quadratic formula. So we know that this guy is our A, we have our B, we have our C, and let's go ahead and put it right into our equation. So we've got x is equal to negative B, so negative 2.5, plus or minus square root of b squared, so negative 2.5 squared, minus 4ac, and all divided by 2a. Okay, we're going to simplify this guy here. We've got negative 2.5, so that's going to be positive 2.5, plus or minus the root of, and we're going to just do simplify what's under the square root first. And we get 10.25 divided by 2. So here we're going to have two cases. We're going to have our first solution, which is what happens if we have positive square root of 10.25. And our second solution is going to come from what if we have a negative square root of 10.25. So we'll pop that in the calculator, and here are our two approximate solutions. So what did we just find? We just found that when we set these two equations equal to each other, they're equal when x is 2.85 and when x is negative 0.35. So we just found the solution to this system. It's the x values that make these two equations equal to each other. Graphically, what did we come up with? Well, we were asked to find the points of intersection. So what we came up with were the x values of the points of intersection. So if we were to come up with the y values for this point and for this point, all we have to do is plug each of these x values into either of these two equations. Now it's easier to plug it into the linear one, so why don't we do that? So let's find our y value of these points of intersection. So we'll just do a little line in between. And our first y is going to equal, we've got 0.5, and instead of x, I'm going to put 2.85 plus 4. 2.85 plus 4. I'm just plugging it into our linear equation up here. 2.85 plus 4. And then our second y value, we'll just do them at the same time. Our second y value is going to be 0.5, and then instead of x, I'm going to put 0.35 plus 4. That should be negative 0.35. Okay, so let's throw those both in the calculator and see what we get. So what did we find here? We found 2 points of intersection. The first one is 2.85, 4.25, 5.425. And the second one is negative 0.35 and 3.825. So for the next examples, I'm not going to do the entire points of intersection. It's just too long. I want to give you an idea of how to find those y values if we need them. But the most important thing is, can we figure out which strategy to use to be able to solve for x? One last thing I wanted to talk about is, how can we tell that we've actually calculated this correctly? Well, there's 2 ways we can solve this. We can solve this algebraically, which is what we did, looking for these points of intersection. We can also solve it graphically. So what if we were to graph these 2 things? So here are these 2 functions graphed. We have the parabola. This is f at x right here, f at x. And then we have our line, which is g at x. And just like we predicted, there's 2 points of intersection, one right here and one right here. And can we tell what these points are? This looks like it's on the negative x. So the negative x point of intersection we got is negative 0.35. That makes sense because it's less than negative 1. And it looks like it's just less than 4 in terms of a y value, and that's exactly what we got. So we have this point of intersection. We came up with it. This one, let's see if it matches with the point of intersection we found. This looks like the x value is just less than 3, and look at that. We got 2.85. It looks like the y value is just over 5, and look at that. We're geniuses. Now that we know how to do this, and we did it once, we're going to try it 2 more times, and we're going to do it a little faster. I'm not going to look for the y values just to save time. We know how to find the y values. I'm just going to look for the x values. So we're going to try these 2 equations now, and we're going to take notice because the solutions are going to be slightly different than what we just got. So let's now try to find the point of intersection of this linear quadratic system. We got a quadratic, we got a line. Point of intersection is what we're looking for. So let's set it up by setting them equal to each other and starting to solve the equation. So you do that right now. Pause the video, set these guys equal to each other, and start solving the equation. Did you get this far? Did you set them equal to each other? And simplify. After this step, what do we got to do now? We could try factoring this. Look for 2 numbers that multiply to 7 and add to negative 3. No numbers exist. So what do we have to do? The quadratic formula. So start plugging those numbers into the quadratic formula and simplify. Pause the video and try that now. If you plugged into the quadratic formula, you should get something like this. If you didn't, go back and check your answer carefully and see where you made a mistake. So now we are stuck. Why are we stuck? Because of this. What's underneath the square root is a negative number. And we know we cannot take the square root of a negative number. We can check in our calculator. Our calculator will say error. So what does this mean? This must mean that there is no x that exists such that these functions will ever be equal to each other. So that means that there is no solution, and that happens sometimes. That's only going to happen when we're using the quadratic formula and we get a negative under the square root. We're going to get 2 solutions, just like normal, if whatever's under the square root is a positive number. But if it's a negative number, there's going to be no solution. How can we make sure we didn't make an algebraic error? Why don't we quickly graph this? So here are the 2 functions graphed. Here is our parabola, so this is our f at x. And here is our line, so this is our new g at x. And you can see that when they're sketched, this line is never going to touch this parabola. In the previous question, the line was running right through it. That's how we got the 2 solutions. Here we have no solution, so it makes sense what we have algebraically. Let's try one more equation, and this example is going to have a slightly different solutions than the 2 that we just found. Okay, so one more time, let's do this. We're finding the points of intersection of this system. So let's set it equal to each other. Start simplifying, and then we'll pick a strategy. So pause the video and start simplifying or setting them equal to each other and simplifying now. If you've set them equal to each other and simplified, we should have something that looks like this. So how to solve this guy? We could try factoring. Two numbers that multiply to 4 and add to -4. So they do exist. It's going to be -2. -2 times -2 makes +4. -2 times -2 makes, adding them together makes -4. So we could factor, and that's absolutely the way we should solve this. I'm going to force us to just use quadratic formula just this one time because I want to show you something interesting that happens. Okay, so just to be clear, factoring, much easier. That's the way we should solve this. Just for the purpose of learning, I'm going to throw this into the quadratic formula just so that you can see something funny that happens. So we're going to put -b plus or minus the square root of b squared. So we -4 squared minus 4a and c. Just filling in our quadratic formula. This is going to change to +4 plus or minus. We're going to work out what's underneath this square root here. So -4 squared, that's going to be 16 minus 16. This actually works out to 0 over 2. So in the previous examples that we did, this was a positive number. This was a negative number that gave us no solutions. And then it can also be 0. What happens if it's 0? Do we have two cases? Let's check. So typically at this point we would break it up into our cases. We've got 4 plus square root of 0 divided by 2. And then our second case is 4 minus the square root of 0 divided by 2. What does this equal? Well, 4 plus 0 divided by 2 is just 2. And again, 4 minus 0, that's the same thing as plus 0, divided by 2 is going to be 2. We get the same answer once. So here in this particular case, there's only one solution. That's it. So we had no solutions when we had a negative number under the square root, and we had two solutions when we had just a positive number under the square root. So in this case is where we had two solutions. So we have these three cases that emerge when we're solving linear and quadratic systems. So what is this going to look like visually if there's only one solution? We know what two solutions looks like. It just looks like a line going through a parabola. We know what no solutions look like. It just, the line is going to miss the parabola. What does one solution look like? So here is what these two graphs look like when I sketch them in Desmo. So here again is our f at x. Here's our parabola. Here's our line, g at x. And it intersects each other, but how many times? Just one time. It's just like right at this point right here. Looks like it's at this point right here. So what's the x value here? The x value is 2, and that's exactly what we got. So one solution just looks like this. This is called, when this happens, we use a special word, and it's called tangent. So when a line is tangent to a curve, it means it just hits it at one exact point, just one point, okay? So this is what it looks like. Let's go over some takeaways from this. Solving a system of equations just means finding points of intersection, and it's not actually that difficult. We were just dealing with parabolas and lines. You can deal with any two equations. All you have to do is set them equal to each other, and then we're just going to use all of the knowledge that we've learned before to just solve them. So sometimes we can get two solutions, and that's going to happen if we're using the quadratic formula and that number under the square root is positive. Sometimes we'll get no solutions if they never intersect, and that will happen when we get a negative number under the square root. And sometimes in a very special case, we're just going to get one solution because the curves are tangent to each other. And that will happen when we have a 0 underneath the square root. So let's try a problem-solving question with this knowledge quickly. So skeet shooting, it's this sport where these clay discs are shot into the air, and you actually shoot them out of the air. So while skeet shooting, the height of the disk is modeled by this function here. So it makes sense that the disk is going to be propelled and it's going to come down as a parabola, right? So it's a parabola, where h at t is the height in meters and t is seconds after the disk is released. The path of the bullet is modeled by this function. So a bullet is coming to hit the clay, and it's generally aligned, probably because how fast it's going. And it has the same units. How long will it take for the bullet to hit the disc? How high off the ground will the disc be when it's hit? So if we were to just guess at this sketch of this thing, we could throw into decimals, but most likely the disc is going to be going up in the air and come back down, right? Because it's a parabola. We know the parabola's facing downwards. And then the bullet is probably going to come maybe like this. Maybe it hits it twice, maybe it hits it once. We're not certain. Maybe this parabola comes down this way and the bullet's going to hit it twice. So we got to figure that out with math, okay? But at some point these two things are going to intersect. So how can we find when these two curves are going to intersect each other? Well, we're just going to set them equal to each other. So what happens when h at t is equal to b at t? Well, let's find out. So we're going to put h at t is negative 5t squared plus 32t plus 2 and set it equal to our linear relation. Okay, and I'm going to move everything to one side. So I'm going to bring the 5t to the right, minus 32t minus 2 plus 31.5t plus 1. And let's simplify this. So we have 5t squared. We've got 32t plus 31.5t. So we're going to have negative 0.5t. And then we have minus 1. How do we want to solve this thing? I know, by the way, we previously solved all of them with the quadratic formula. You don't always have to use the quadratic formula, right? Factoring is still a great option if you can do it, and sometimes it's a lot faster. Here I can see I've got a decimal, so I'm not going to try factoring. We're going to go right to quadratic formula. So we've got x is equal to, here is our a value, here's our b, here's our c. We've got negative 0.5 plus or minus the square root of negative 0.5 squared minus 4ac, all divided by 2a. So let's simplify specifically what's underneath the square root right here. So we've got 0.5 plus or minus. Let's see what's under that square root. And I got 20.25. So how many solutions are we going to get here? Well, we're going to get 2 because we've got a positive number underneath that square root sign. So our first solution is going to be 0.5 plus this, plus 20.25 divided by 10. And our second solution is going to be 0.5 minus 20.25 divided by 10. So let's throw those in the calculator and see what we get. So here are the two values that I got. I've got 0.5 and negative 0.4. So there are 2 points of intersection just like we predicted. One of them is positive, so that must mean it must be here. And one of them is negative, so it looks like we drew our parabola the right way because the other point of intersection is back here. Now we know that this is time and height, right? So does it make sense that the bullet hit this hit the clay marker at negative 0.4 seconds? No, that makes no sense. So this answer we call extraneous. It doesn't make sense for this particular context. And this must be when the two hit each other. So the question is, how long will it take for the bullet to hit the disc? It will hit after 0.5 seconds. But how high off the ground will the disc be? Well, we've got to plug in that 0.5. So we know that this is 0.5 seconds. We've got to plug that guy in and see what we get for height. And because it exists both on the line and this parabola, this point, we can plug in that 0.5 into either of these to find that y value. So let's plug it into the line and see what we get. Okay, so we know the time that they hit each other, that they intersect, is 0.5 seconds. So I'm going to throw that 0.5 seconds into the easier equation, that linear one. So I'm going to throw in that 0.5 into the bullet equation, and we get 16.75. So therefore our conclusion is, therefore the two will intersect at a time of 0.5 seconds and a height of 16.75 meters.